Hello, everyone, and welcome back. Before we begin here today, please like and subscribe because it really does help out the channel. So what we're going to be covering today is our first video in calculus, where we are taking derivatives of the most simple expressions that you will find in calculus. So all of these derivatives, we're just going to do three of them, are going to be of the form, if I get the pen working here, of the form of d dx, our derivative, ax to the power of b. This is the most simplistic form a derivative can have, where a is just a whole number, or any kind, doesn't have to be a whole number, but just a real number. And the same thing with b, is just to the power. So when you have a derivative being taken with respect to x for this type of formula here, what happens is that you're going to keep the constant, a constant, that number a, and then you're going to have your x value that is still attached to it. Then you're going to take the b, which is to the power of x, and you're going to drop it down in front of a. And then your power, since you're dropping the b, is going to be b minus 1. You have to reduce the power. And then you just end up with b times a, which is a number, times your variable x with b to the minus 1. And that would be your overall progress or process of what you would do to find derivatives of this form. So let's give it a try here. So starting with number 1, we're taking the derivative with respect to x. Whatever you see here in the bottom with dx, the x is telling you that's the variable you're taking the derivative for. If it was t, like with our second one up here, we would take the derivative with respect to t. So you have to make sure that you are taking the correct variable, the correct derivative of the variable indicated here. So we are looking for x, which this so happens to be x. We're not doing any mixed derivatives just yet. So we're taking the derivative of 5x to the power of 3. Well, it is of this form previously shown up here of ax to the b. So what we're going to do is we're going to keep the constant of 5, just carry it over, don't change it just yet. We're going to keep our x, and then we're going to take our 3 and we are going to drop it in front of the constant 5 there, so 3 times 5, and then our power is going to be reduced by 1. So we end up with 3 times 5, x to the 3 minus 1, which this ends up being 5 times 3, which is 15, and then x squared from 3 minus 1. And that's our final answer there. So our second problem, we're taking the derivative with respect to t, and it is of t to the power of 4. So this is still of the variation that was shown up here. It's just that our a value is technically 1. So it's 1t to the 4th. So whenever you have that, you can just ignore the 1. Because if you multiply anything by 1, it's 1, right? So what we're going to have is 1, and then you're going to have t, and then you're going to take the 4 and drop it in front. So there's the 4, and then the power will reduce by 1. So essentially we would have 4 times 1 times t to the power of 4 minus 1, because our a value is just 1 here. So in the end, we end up with 4t cubed as our answer. So don't let this trick get you tripped up just because there's no constant there. If there's not a constant shown in front of our variable, it's 1. The a value is 1. All right, I think I can squeeze the other one in there. All right, so then our third one is dx, or the derivative with respect to x. And it's going to be 6x to the 2/3 power. So this is still of the same variety as shown up here. A will be 6, and our B will just be 2/3. It does not have to be a whole number. It can be whatever it needs to be, or whatever it currently is. In this case, it's 2/3. You're just going to subtract 1 from it and still drop it in front of the constant. So let's do that. So carry your constant across, and then the variable, and then take the power and drop it in front, so 2/3, and then your original power, subtract 1 from it. So essentially we have 2/3 of 6, which is 4, and then we have x with 2/3 minus 1, which ends up being minus 1/3. You could write it like that, or if someone wants to be fancy about it, you could go as 4 over x to the 1/3 power. Because anytime you have minus power, it just means it's being divided by that power. Or the whole process is being divided by that. So you could write either or. Does not matter. So this was overall demonstrating that it does not matter what your a value is, your constant, or what power you are to. It will follow this nice, easy format displayed here of copying and pasting your constant with your variable. This time it's x, the second one it was t, and the third one it was x again. You're going to take your original power and drop it in front of your constant, and then take your new power minus 1 from the old. So this is how you solve for polynomial derivatives with easy expressions of a constant times a variable to some power. So I hope this was helpful, and if you want to see more problems solved in this variety, we are extending more videos, or making more videos and extending this out to make it a little bit more difficult. If you want to see those, please check out those videos on our channel. Thank you for watching, and hope you have a great day.